So on your paper, you should have already taken and folded over that right-hand side so that you have these right here on the front, and you should have cut along the lines or cut in between the words so that they can flap open, or the flaps can move open so that you can put notes on there. Now, we are starting our unit into quadratics. When we're talking about quadratics, we are talking about equations that have an exponent to the power of 2. When we put into the calculator what's called the quadratic parent function, so right now where it says quadratic parent function, move the flap open, and I want you to write y equals x squared. So when you put in the calculator y equals x squared, it gives you this curve. This curve is called a parabola. It looks like parabola, I get that, but it's pronounced parabola. So first off, you should have already had in your slat underneath quadratic parent function y equals x squared. Now flip over the one that says parabola, and I want you to write the graph of a quadratic function, a U-shaped curve. Now, as we go through and do this, over here where your graph is, my pen doesn't want to be friendly today. Here, I want you to draw a line, and I want you to write parabola. And then on parabola, I want you to write the quadratic parent function up here, which is this is the graph of it. I want you to write y equals x squared. Sorry about the, I'm going to see if I can write it better, but the tablet's acting kind of strange today. So right here, we're writing parabola, and we're writing y equals x squared. Okay, so that should be written down. The parabola also, when it says the graph of a quadratic function, this function, the parabola, okay, it's always going to make a U-shaped curve because of the squared, and we're going to work on that a little bit later. Now, you have some other attributes about a quadratics that you're going to need to know the definition of. The other one is, one of the most important things is called the vertex. Flip open the flap that says vertex. The vertex is the highest or lowest point on a parabola. It's the maximum or the minimum. Now, when you're looking at this right here, I see that the highest or lowest point is right here. And I want you to put a dot on your graph. And I'm going to see if I can write with the tablet or if I have to try and do it with my mouse, which I may have to. This is my vertex. It is it's at the bottom of this curve. So if it's at the bottom, in this case, it's a minimum. Now, another way that we talk about vertex that you need to add in there, it's the point where the parabola, darn it, let's see here, where the parabola changes direction. That's the vertex. When you look at the other one, oh, let's see here. I'm going to try it. Okay, frustration. On the other one right here, on the other parabola they have drawn, put a dot. That is the vertex of that parabola. I'm trying to write with the mouse here. And in this case, it's at the top of the parabola. It goes up and then goes back down. This is a maximum point. So you need to write maximum. If if you notice the difference, the vertex that is a maximum has a parabola that opens downward. A parabola that opens upward has a minimum. Now, the next one on this where it says axis of symmetry, don't flip over the thing yet. I want you to write on top, right underneath where it says axis of symmetry, write AOS. You're going to find that on your worksheets and on some of your papers, it's going to ask you what is the AOS, and they're talking about axis of symmetry. Okay? So here in my class, right here on the front, you see that mine says, it says axis of symmetry, and I just have AOS written underneath of it. Then when you flip open the flap, what you're going to write underneath there is that this is the line that divides the parabola in two equal halves. So, let's see if I can get a good color. Here we go. Right here, these are my axes of symmetry. If you notice on this axis of symmetry, it's if I folded this blue line in half, it should be even on each side. Okay, so this one, let's see here. In the green is my AOS. Now, when you go to find the equation of the AOS, it is going to be x equals a number because it is a vertical line. It is actually going to be the x number of the vertex. So this number right here is the x number. Let's see if I can write now. Number of the vertex. That is the x number of the vertex. So, for example, on the one over here to the left, the top one, that is x equals 0 because that vertex right here is 0, 0. The bottom one down here, the vertex is actually 1, 2, 3, up. Okay, so it should be 3, 2. And that axis of symmetry is x equals 3 because it is the x number of your vertex. Now again, this is the first time you're hearing this. We're going to go over this each day to be able to understand the vocabulary and to remember it. So don't be frustrated and saying, oh my gosh, I don't get it or whatever. It's a matter of just understanding the definitions, memorizing them, and going from there. Now, symmetric pairs. Whoa, nice line. All right, try again. Symmetric pairs, flip that open. They are the ordered pairs that are reflected across the axis of symmetry. When you're talking about symmetric pairs, you're talking about points that are the same distance away from the AOS. So here's one. Nice dot, Crawford. All right. So you have 1, 1, -1, 1. You're also going to have 2, 1, 2. Right here is going to be 2, 4. And the same distance away over here is -2, 4. What do you notice about these ordered pairs of symmetric points? What's the same? Okay, which one is the exact same, Ali? Okay. The Y numbers are the same. See, look, 4, 4, 1, 1. Write down in here, right here, that the Y numbers are the same. If they're symmetric points, the Y numbers are the same. Okay, so the Y numbers are the same. Okay, writing with a right-handed mouse is tough when you're left-handed. All right. The y numbers are the same in an ordered pair when they're symmetric points, and you'll see that in just a second. Now, flip over. We should know y-intercept. Y-intercept is the point where the line crosses the y-axis. Okay? Those points are, they have 0, and then there's a number in the y spot. We've done that many times over. That doesn't change. For example, over here on the bottom one, because it's already up, I have put a dot right here. That right there is my y-intercept. It's just where it crosses the y-axis. There's nothing different from that, linear or quadratic or whatever. The x-intercept is probably the most important thing. It's the most important thing when we're dealing with quadratics. Okay? The x-intercept are actually the solutions to a quadratic function, and we'll deal with those later on when we start doing more with them in the next units. But they are the solutions to the quadratic. They are the roots of the equations or the zeros, and we have talked before about zeros. But somehow, oh, I guess you can't highlight and see that on there, can you? Let's see it. What about blue? Nope, none of those highlighted work. Well, pink, maybe. Oh, that did not work. Try again. All right, so I guess I'm just going to circle it, underline it. Zeros. Most important thing, when they're asking for a zero, they're asking for the x-intercept. That's where they cross the x-axis. So see, I'm putting dots right here. Those are your x-intercepts. Those are your zeros. Let me give you a second to finish writing that down. All right. Now, with your pencils down, I want you just to look at this. I want you to look at the PowerPoint. We're only going to go through a couple slides. The whole slide, the whole PowerPoint is on the YouTube and on my website to be able to go through it all in general or in detail. We will go through all of this each day, and we're going to look over it because we have to get this stuff memorized. Brain-based learning says we learn in color, and it says that when you review it a little bit each day, it goes deeper into the memory. Okay. The quadratic parent function, y equals x squared. Don't write any of this down, just watch. This curve right here is called the what? Parabola. I know it looks like parabola, but parabola. I know, and I say parabola to help me remember it too. Now, the vertex is the point where the parabola changes direction. Is it at the bottom of the graph or the top? In this one, it's at the bottom. So is that a maximum or a minimum? Minimum. See, now look. The vertex, they put a dot on it. Axis of symmetry is x equals whatever the x number is of the vertex. Okay? Symmetrical points have the same y values. They are the same distance, right here, they are the same distance away from this axis of symmetry. And if you look in a table, you have to be able to find the symmetric points, and the way you look for them is by the matching y numbers. Okay? See, if you look, you've got 36, 36, 25, 25, 16, 16, 9s, 4s, 1s. 0 is the only one that doesn't have a date to the prom. It's the only one that's by itself. Look at the next one. How is this equation different from the quadratic parent function? It says, negative, what says minus 7, right? Negative 7, minus 7. How did the parabola move? How did it change? It went lower, right? It shifted down. It's not sitting at 0, 0, right? If you look at this table right now, can you look and see what the vertex is? Can you find your symmetric points and go back through and find where the one that changes direction and it doesn't have a partner point? Your vertex, you should have found at 0, negative 7. Your axis of symmetry, again, where you fold it in half, is still x equals 0 because it's still on this line. All it did was shift down. Your symmetric points, you should be able to find them by your matching y numbers. Now, the last example I'm going to show you on this is this one. Don't worry about this crazy equation, but you will see it again. It's a quadratic equation, okay? Now, can you look at this and see, is there a maximum or a minimum? It is a minimum where the point changes direction, where the vertex is. Could you tell me what that ordered pair is? Now, it's not 0, -3, because look, -3 has a partner point up there at -3. -6 and -6. Your vertex is right here where the the parabola changes direction. Now your axis of symmetry, x equals the x number of the vertex, is x equals -2. Your symmetric points, there's many more than just what they have in the blue, but they only listed just a couple of them. Okay?